Okay guys, in this experiment we will see two new equipments that we haven't used before, and that are the function generator and the oscilloscope. Okay, we have seen these two in the last few experiments. One is the DC power supply, and the other one is the multimeter that is used to measure DC quantities. And also we have seen that it has AC quantities to measure as well. We will see that how we can use this for AC. So these two equipments, which is one is called the function generator. It is equivalent to this DC power supply, but in case of AC, right? And to measure the quantities, we use multimeter in case of DC, and also some AC quantities as well. However, we will use oscilloscope. This is called oscilloscope to measure the AC quantities. Okay. So in the first simple experiment, we'll just have a waveform. We will generate a waveform in this function generator, and we'll just observe this waveform here with certain quantities. Okay, like the frequency, time period. Definitely is related to frequency and time period is related to each other, and also we'll see the amplitude and the phase and the offset value. Okay, so let's see this what we have here. If you just turn this on, you will get this screen. Okay, and you'll get the screen, and you can see here that we have certain quantities like the frequency, phase, amplitude, and the offset that you can easily set from here. Okay, so this is the frequency. If you want to set any frequency, just click on the frequency and you can set it. For example, 1 kilohertz. Okay, similarly, if you don't want to set the frequency, you can also do it the time period, and definitely the one of the time period is the frequency. Okay, so but here we will just do it for the frequency. Then also you can set the phase, but here we don't need to set that phase. Then we have the amplitude value. You can set here either 1 or 2 or whatever. Let's make it 2. Okay, and that's it. Okay, you can also enter from here. So let's say for example 2 and enter. Okay, and similarly offset value, we will look at it later on, that how it affects the value of the waveform. Okay, definitely there are other things like high level, low level. That's not needed, just leave it to default. Similarly, if you for the amplitude, this is V peak to peak, so I set it to 2 volts V peak to peak. You can also set it to another units, maybe RMS or dBm. Okay, so it's upon the requirement, but here we will, in this experiment, we will deal with the V peak to peak or only V peak. But in you have seen in the multisim, there we have only we have the option of V peak, but here we don't have option of V peak. We just have an option of V peak to peak. Okay, once everything is set, then you have to turn it on so that it can activate. Okay, it can activate, and output, you can see that it's a wire here. Okay, so output I can connect from this, so output can be connected with this wire. Okay, now let's go to the oscilloscope. Once you have set everything here, which is like the, okay, now there's another thing, which is where shapes, like you have square or ramp, triangular or pulse or whatever you want, you can set from here. Okay, once you have set everything, frequency, amplitude, offset value, phase value, and the shape here, then you can we can observe this on oscilloscope here. So here you can see that I have connected the two terminals of the function generator with the two terminals of the oscilloscope. But you can see that here it start displaying something, but it's not really giving the clear picture. Okay, so for this I will just press this auto set, and it will set the scales accordingly to the values that we have given here in the function generator. Okay, or to the input, whatever input we are giving here, Okay, it will set the values according to the input values so that it can be displayed. The waveform should be displayed correctly. Okay, so you can see here. Okay, and not only this, it's giving the peak to peak value, cyclic RMS or RMS value, this period and the frequency. Okay, so you can see that peak to value is 2, frequency is 1 kilohertz, which we have already set here. Okay, so I think it's correct. Definitely there is small deviation from 2, which is understood because of the equipment, and definitely there is stuff wires and other things. Okay, so what else? Okay, now if you want to, this is like several cycles it's displaying. If you want to display the one cycle, it will also display you just one cycle. Okay, let me go back. And also if you want to take the Fourier transform of that, or DFT or FFT, it can, and you can see here this is a peak at 1 kilohertz. Okay, so okay, it says a peak at 1 kilohertz. Okay, so let me go back. Okay, there are other things that will be of interest. One is the measure, what things we want to measure. You see here's the channel 1. Okay, now since I told you that I can input 2, so one is channel 1. Okay, and also this is the channel 2. Okay, so since we have just channel 1 here, so we can also input here the channel 2. Okay, so now the other things, before going to the measure and how we can do that, also you can set the scale. If you see here, you have 500 millivolts. It means that this box is one box is 500 millivolts. Okay, and similarly here it's like 500 microsecond. So 500 millivolts, one, yani 500 plus 500, which becomes 1. So it means that this peak value is 1 volts, which is what we set. Okay, so either you can measure from here, also you can just do it here, or also you can, if you want to adjust, you can adjust the values. Okay, oh sorry, not here. Okay, like for example, now it's become 1, so 1 volts. Now one box is 1 volt, so you can adjust the value. This is for the channel 1. Okay, and for channel 2 you have this, but we don't have channel 2, so we cannot do anything about it. However, here this is the base. Okay, the base time base. If you want to change values, okay, like 100 microsecond now becomes, okay, now it's become 500 microseconds. So accordingly the waveform either expands or contracts, as depend. Okay, now this is for the position. If you want to change the position, okay, here or there, just for maybe phase shift or something. Similarly here, sorry, this is for the channel 2, this is for channel 1. If it's not centered, you can center it accordingly. Okay, at 0 scale, just to measure the correct values. Okay, now again come back to the measure. If you press on the measure, you will get these values, and you can also select your own values. This shows channel 1 RMS value, which is 717 millivolt. Channel 1 peak to peak is 2.06. If I don't want the RMS and want some other value, click there, source channel 1 or maybe channel 2, whatever you want, but channel 2 is off. So channel 1, type whatever I want, minimum value for example, which is -1. So if I want minimum value, it will display here the minimum value. Okay, but if I want max or RMS or rise time, fall time, other things, okay, duty cycle, phase, frequency, whatever I want. So let's go set it to peak. No, it was RMS. Okay, so similarly for the phase 2, channel 2, we have set at the phase and max value, but you can set to other values, but since we are not using the channel 2, it's okay. So now, okay, there's another thing that might be interest to you guys, is the cursors. Okay, the cursors, now it's off, but if you want, for example, any instant value like the time, like for example, I can say, okay, what is the state of this at this instant, what is the value, what is the peak value, what is the instant at which this peak occurs. Okay, so how I can do that? Then I can use this cursor, so I can say okay, on, and also now this is for amplitude, so it shows the amplitude, and here I can just adjust, like you see here. Okay, and cursor values can be read from here. Okay, this one, so the peak is 1, so this is another way to read the peak value as well. Okay, peak is 1 and the lower peak is -1. Fine, this is amplitude. If I want the time instant, I say type time. Okay, and then I can say, for example, the peak, where the peak occurs. So it's like an instant 1.76. Okay, and minus here is because it's relative, it's considering this as a 0, so it will be negative. Okay, so -1. If you go above this one, it shows the positive microsecond, and also the value of the voltage and at the instant that it occurs. Okay, I think these are the important things. So again, I will just show you the whole picture, how I did it. Okay, so I hope, let me turn this on as well, it gets off. Okay, so I think in this way I just generated the waveform and measure it using a oscilloscope. Okay, there's no circuit involved in there. Okay, one last thing is that you see there's an offset. So let's see what is the effect of the offset. For example, if we set the offset value to 1 volts, oh sorry, one should be 1 and volts. Okay, so like you can see that the waveform is shifted above by 1 volt. Okay, let me, okay, now you can see that. So this is like added 1 volts to the AC value that we are generating. Okay, so this is the for offset. Okay, now we move to a next part in which we will just build a small circuit and use oscilloscope and function generator. Okay guys, so let's build this circuit, and gives the value of 4 sine omega t and 5 kilohertz as the input, and we will measure at the output at A and B. Will measure the VAB using the oscilloscope and then the AC voltmeter. We know that AC voltmeter will give us the RMS value, so RMS value also we can measure with the oscilloscope, so we can also compare, and oscilloscope definitely will give you the peak to peak or the peak value. Okay, so let's see, we have the two resistor 100 and 150 ohms, as you can see here it's connected like this. So at the input should be connected to the function generator here. Okay, so I will just connect the positive and the negative here. Okay, and I have to set the value, since we have 4 sine omega t with frequency of 5 kilohertz. So let's see this. We have the okay, offset we don't need it, so we just say okay, it's 0. Let's see, the amplitude is, since we have the 4 volts peak value, but here we have peak to peak, so we have to set it to 8 volts peak to peak. And then we have the frequency we can set from here, which should be 5 kilo. Okay, now it's been set, all set. Now here I will just say auto reset. Okay, just to make sure everything is okay. Now I have to connect the output A and B, which is this one, okay, to the oscilloscope to see the value. Okay, so I will just connect here positive and then the negative here. Okay, now it's being connected, this wire is being connected with the oscilloscope. Okay, and then definitely to display the proper waveform, set the autos button, and you can see here that we are getting some values. Find the RMS value. Okay, let's see here. Yeah, so we have, let let me set this to channel 1 peak to peak, which is coming out to be 3.38 or 6. Okay, and let's set it to be the RMS value, which is 1.16. so in this way I basically measure this peak to peak, which is 3.36, and definitely it's, since we need the peak value, so we should divide by 2. Okay, the same thing we can also measure using the multimeter, since we have the AC here, you see AC volts, AC current. Okay, so I can also measure the RMS value. When I measure the voltage here, A and B, it will give you the RMS value of the voltage. Okay, let's do that. Let me put the wires here. Okay, so two wires, I have connected two wires for the two terminals. This is the positive one, let's connect to the positive here. This is the negative one, so let's connect it to the negative here. Okay, now turn this on. Okay, set to volt DC, so we don't need DC, we need AC here. So as you can see that it's displaying 1.12 volt AC, which is RMS value, and you can see here from the oscilloscope you have 1.15 volts, so it's like really close. Let me give you a whole picture here. Okay, so this is a circuit. The output is from the function generator. The output you can measure from the oscilloscope, and you see that we didn't use the channel 2, but we will use in the next experiment. Why we need the channel 2 here? Because if, for example, in AC normally we use some reference, so sometimes we connect one channel to the input, the other to the voltage that we want. Okay, or we want to compare, or there must be some phase difference or the amplitude difference or whatever. So it's sometimes we need a reference, so that's why we need the two inputs here. If you want to display the second channel, you can display like this. Because it's not connected, you can see 0 here. Okay, so this is all for this lab. See you in the next lab.